Okay, so in this lecture we're going to start chapter 12 and sort of finish up chapter 11 all at the same time. And we're going to talk about waves. And we're going to start off and we're going to use this equation, v equals lambda f. That's going to still be a very important equation. And we have velocity equals wavelength times frequency. Okay, and I want to start off, I want to talk about electromagnetic waves. These are very important and they're very special because they do not need they are like self-sustaining. They can travel through otherwise empty space. Okay, so we had water waves, and basically you need water to have water waves. Right now I'm speaking to you using sound waves. I need air to make sound waves happen. If there was no air in this room, there would be no way for the vibration of my vocal cords to reach the microphone that is picking up the vibration of my vocal cords via pressure waves through the air. But electromagnetic waves, they are oscillating electric fields and magnetic fields, and so they're kind of special. They can go through outer space with nothing to support them. And you've probably seen this in some other class. Hopefully you have radio waves, microwaves, infrared, visible light, ultraviolet, and X-rays and gamma rays. And that right there is a Greek gamma. So gamma rays. Okay, so now all of these things, all of them okay, all of these travel through a vacuum at the speed of light, and that's 3 times 10 to the 8th meters per second, and it makes sense that they all travel through a vacuum at the same speed because they're all the same thing. We call them by different names, but basically we're just breaking up the exact same phenomena into little packets that we kind of deal with. You know, radio waves is what we use for broadcast signals through the air. Microwaves is also used for communications like point-to-point communication and cooking our food. Infrared is used for on your remote controls. Visible light, we use that all the time with our eyes. Ultraviolet, we use that to make sure that our money is not counterfeited, and also to tan. X-rays to see if we've got broken bones, and then gamma rays. We can use that in nuclear medicine to try to kill tumors. and that's also maybe also sort of detecting terrorist nuclear materials. Alright, so all of these things are the same thing. The only difference is this is low to high energy. So radio waves are low energy electromagnetic waves, and then gamma rays are high energy electromagnetic waves. Okay, so now we're going to figure out a couple, we're just going to do two examples. I'm going to say, if we look at radio waves are going to be, we're going to use V equals lambda F. And I know typically that this is a typical FM radio station. And so we're going to figure out F for that. F is going to be V divided by lambda. I'm sorry, I already know F for that. So we're going to say lambda is equal to V divided by F. So my V is going to be 3 times 10 to the 8th meters per second. And my frequency is going to be 97.7. Now what does that capital M mean? Well, that capital M is a SI prefix, which you guys should know, which is mega, and so it's mega, and so mega is 10 to the 6 hertz. And so I'm going to get that the wavelength of that is going to be 3 to the 8th divided by 97.7 to the 6th. I'm going to get 3.07 meters. So my radio waves have a lambda of about 3.07 meters, and they have a frequency of about, well, 97.7 times 10 to the 6 hertz. And then I'm going to look at, say, blue light. Has a lambda of around 400 nanometers. And so we're going to say F equals V divided by lambda. So we're going to say 3 times 10 to the 8th meters per second divided by 400. And now what does nano mean? Take a second and remember what nano means. Times 10 to the negative 9th meters. And so I'm going to get a frequency there, 3 times 10 to the 8th divided by 400 times 10 to the negative 9th, and I'm going to get 7.5 E14, so 7.5 times 10 to the 14th hertz. So down here, my lambda is about 4 times 10 to the negative 7th meters, and my frequency is 7.5 times 10 to the 14th hertz. Okay, so what we see is that as we go from low energy to high energy, the frequency, we go from low frequency to high frequency. So frequency and energy go together. So low frequency to high frequency means low energy to high energy, and then correspondingly, as the frequency gets more and more, the wavelength gets shorter and shorter. That's that for that lecture.